Functions that execute a bunch of code are very awesome, but often we want to get back a value back from a function. In this lesson, we're going to talk about how functions return a value and get the result back. Returning a particular value is actually why often we call a function in the first place. The reason why we are calling the index function here is because we want to pass a value which is 4.5 and get the index of that particular value as an output and also store that data in a variable. Let's actually look at the mechanics of returning values more closely in our getMilk example. In this case, we are supplying an amount of money as an input, and we are using our input to make a calculation. In other words, we are dividing the amount of money by the price of milk to calculate the liters of milk to buy. So the question is, how do we return the result of this calculation? And the answer is, we use the keyword called the return keyword, then followed by the value that we want to return. We write return liters, and that word return is actually a Python keyword. When Python hits this line of code that says return, it will exit the function and will return whatever result that comes after that keyword. So in our case here, getMilk is outputting the value inside liters, and the call to getMilk is actually the same as before. We have the function name and a value for an argument, say 20. However, if I run this program, then we get back nothing because our function is returning a value, but we are not storing the value anywhere. So what you will typically find is that when a value is returned by a function, then we're going to be storing that value in a variable. So enough for the theory. Let's now put this into practice. Suppose you are working for a cutting-edge Silicon Valley company and you are building a calculator. You are the engineering lead at the team and have been assigned incredibly important tasks of programming the multiplication button. As a challenge, can you do the following? In your code editor, create a function called times and have this function text to input. It needs to multiply this input together and provide the result as an output of the function. Also, you need to test this function that it actually works. So, call your function and multiply 3 by 5. Store this value in a variable called answer and print out the value of answer on the console. I will give you a few seconds to pause the video and give this a go. You ready? So here is the solution. So the first thing we're going to do is to define our function. We're going to use the keyword def. We're going to give our function a name. We're going to call it times. Now we will provide two parameters. Let's say x and y. Well, you can call these parameters anything you want, by the way. We then have the column. Hit enter and say we want to store the answer of the multiplication in a variable. So we say answer equals x multiplied by y. And then to output the value of this function, we go with returned answer. Now, suppose you called your parameters a and b instead of x and y. Then you have to be consistent. You need to have a and b inside the body of your function as well. So now that I'm done with my function, let's actually test it. So I'm gonna type times 3, comma 5. However, we said we're going to store the value from the function inside a variable. So let's say result equals to the times function. And when I print the value of result and then run the code, then we see the value of our multiplied variables printed out on the console for us. Now, we can actually simplify the code inside our times function a little bit. In fact, we actually don't need this extra line of code here. So I can comment it out with a hashtag, and instead of returning answer, I can return the calculation directly. I can say A times B. And when I run the code once again, then we can see that our function is working and our output is the same. If you've decided to write your function just like this, then you are doing the calculations on the same line as the return keyword, and this is absolutely fine. Now let's continue our story on working at Silicon Valley Tech Company, and I want you to connect this lesson with our previous lesson on data types. Now that you've written your function and submitted your calculator code to the project team, and a moment later your boss comes in and type single quote me, comma, then 5, and after typing this to your code editor, he smiles and then walk away. So let's see what will happen when we run the code. If we actually run this code, then we see the word me displayed 5 times on the console. So this is unexpected, right? The times function does completely different something now. That multiplication symbol is not multiplying when we are passing in a string. The multiplication symbol, in fact, is repeating a sequence. And what this shows is that the Python code doesn't really care about the specific data types it's running on. In this case, both numbers and strings support this times symbol. Now, what this means in practice is that we developers, when we are writing our Python code, we need to have some tests and be aware of the kind of data type that we are working with, and also to detect errors. A reasonable question to ask as well is, Python is really about flexibility. Ideally, Python code should not really care about the types, and this is in contrast to other programming languages like C++ or Java, because Python is meant to be flexible. This is core part of the Python philosophy, in fact. Returning to our topic on function, this is a good time to review and summarize the 3 flavors of functions that we've encountered so far. We've seen functions with no input and no output. We've seen functions with input, and we've seen functions with both output and input. When defining a function, we always have to use the def keyword. Then the name of the function, followed by the parenthesis, and then the semicolon. Also, the very important thing is that the body of the function is also indented. I recommend using 4 spaces, but most code editors will indent this for you automatically. Finally, we've encountered functions that have both input and output. The key thing here is that functions with output have a return statement. The output is whatever comes after the return keyword. And the way to remember this is that in the future, if you ever dating a programmer and you tell them to go to the supermarket and buy some milk, and they never come back, then this is because you haven't told them to return anything. So this wraps up our tutorial. But however, one thing that developers have learned over the past few decades is that splitting up a task into smaller or manageable parts is really important. And it helps a lot. On a small scale, the splitting up of different functionality is accomplished by putting code into functions. And this is accomplished by splitting up bits of code into different files. The rationale behind both of these strategies is the same. They are about managing complexities. And on that note, I want to leave you with something special. In your code editor, type import this and then run the code. You will be greeted with the Zen of Python by Tim Peters. My favorite lines are simple is better than complex and complex is better than complicated. And on that note, I'll see you in the next lecture. Take care.